Today we're going to have a look at object-oriented programming through our assessment task, which is to build a version of Blackjack. First of all, though, let's consider what is object-oriented programming. So, it's a programming paradigm that's largely focused on organizing the data within a system. It's less focused on the logic in the system and more concerned about the data that we're going to have to manipulate in some way. It is a paradigm that became very popular in the 60s and 70s and has largely become kind of the de facto way of building software. So an object is its own data type. It contains data, which we refer to as attributes, and functions, which we refer to as methods. These attributes and functions are described in a class, and when we start using the class, i.e. when we create an instance of the class, it is referred to as an object. So the object in the system is something that contains data and methods. When it's just a class you can think of as a template for an object. Objects allow us to contain all of the data and functions in one place, so we can use them anywhere throughout the system. And it's designed to be used in large systems where many programmers are working on different parts of the system. So we refer to it as being encapsulated. In other words, when programmers are using object-oriented programming, you only need to really worry about what goes into a class and what goes out of a class. So data in and data out. Okay, so let's have a look as an example. Consider a student in a student management system or SMS. What would we actually need to know? Well, we need to know the name of the student, their date of birth, which house they're part of, what classes they attend. And the methods or the things that that class can do in the system or that object can do in the system is create itself. In other words, a new student. We can add that student to a class, and we can add it to a house. If we wanted to extend this further, we'd also have remove from class, remove from house, remove student, those sorts of things. Once we create an object or create a class, we can create many different copies of that. So in our example here of a student management system, we would have many different students where we know they all have the same attributes, they all have the same methods, but they all have their own data. No two students being the same. But we would know that we'd know every name of every student, we'd know the date of birth of every student, we'd know the house they were in, and we could actually then manipulate every one of those objects within the system, which is to say this student can attend this class, this student can move into this house, etc., etc. Okay, so how does this work in terms of our game? So let's consider Blackjack. How would we apply this process to Blackjack? Here we have a card. We have a card in a very analog fashion. And as I'm always saying, we are building software for a digital age, so why do I have this card when this would be better? Here we have the ace of spades. What do we need to know about it? Well, we need to know its suit. We need to know what face it has. It might not have any, it might just be 1, 2, 3, 4, or 5. What its value is, and whether or not it's an ace. Because an ace, we know in Blackjack, can be either 1 or 11, depending on how we want to use it. So how does that look in code? Here's an example in Python, where I've created a class for a card. We have our definition here of an init method or initialization method. You see the double underscores there, that's called a dunder. So we have dunder, init, dunder. And we pass a self, which is just a copy of itself, the suit, the face, the value, and whether or not it's an ace. Then we set those parameters within the actual class itself. We say self.suit is equal to the suit that we've passed into this method. The face is the face, etc., etc. We go down through the list. And that's it. That is a class for a card. It's all we actually really need to know about a card in the system. So if we wanted to use it, we'd actually create a new instance of the class, and then it would become an object. So here we have card equals capital C card, which is our class. And here you can see that we're passing parameters to the actual initialization method that we've defined before. So here we're passing it's a spade, it's an ace, its value is 1, and it actually is an ace, so we need to track that. So if I was to print card.suit, card.face, card.value, the output would be spade, A, and 1. Now, if I wanted to store many copies of cards, I would then append that card to a deck. just a list of different cards in the system. So you can see that we're actually going to then be creating many, many different types of cards, going through all the different suits, creating as many copies of them as we need, and storing them in a single list where we can access all of them as we need. We can then start thinking, well, we've got the base class for a card, we can start using it in different ways. So we might have a hand. We're dealt 2 cards at the start of a game of blackjack. So here we have 2 cards. We have our ace and we have the 7 of spades. So we have 2 cards. We know that the hand contains an ace. Well, we need to know that. We'll need to calculate the hand value, so that's another method. And we'll also want to return the number of cards because the 5 is the maximum number of cards we can have in a hand. So for our hand object, we would have a list of cards. We would have a property to whether or not to find out whether it has an ace in the hand. We would have a method to return the value of the hand, and also to just make sure that if we ask for another card, it's not more than 5. And here we have the code that I've written for the class hand in the example that is available on GitHub. So here you can see we've got the initialization method, and all we need really here is to store a list of cards. And we're not even going to pass anything to it initially because that's not important. So the only thing that the only attribute we care about for a hand is the cards itself. Here we can actually append, so we have a function here to append a card to the deck. To the hand. So we have hand.addCard, and we can pass the card that goes into it. Remove cards, which clears the hand at the end. Here we've got a function to get the hand value. So here we basically go through for every card that I have in my list of cards. We add the value. If it's an ace, we return whether we have an ace or not. If the hand value is greater than 21 and has aces equal to true, then we change the value, and we essentially go through until we can make sure that we haven't actually busted. And then we can return the hand value. Now, it will return that if we are over 21, we will return that we're over 21, but the hand value here that checks whether it has an ace will return whether that minus 10 to it. And then I have just a utility function here to print the hand, which just allows us to basically just test what's going on. So for the logic here, basically we go through and add every single card value that we have in the hand. If the hand value is greater than 21 and has ace, the flag there has been set to true, we'll then go through, and if we have a hand value that's greater than 21, we remove the ace, and just repeat until such time as we're under 21, if possible. And then we'll return the value of the hand. Here we have my initialization of the game. This could be done way better. So I'm going to expect you to improve on this. But it works, and it just creates a simple deck. So here we have the deck, which is an empty list. The suits, which is the 4 suits. The faces, which is what the picture cards will be. And then the values, 11, 2, 3, 4, 5, 6, and then 10, 10, 10, 10. So for each one, in for deck in the range of deck size, so I think I set deck size to be 8, which I believe is the standard in most casinos, or at least it used to be. It's probably bigger now. And then basically it's just a nested loop. So for each suit, in the range of 12, and then go through, and you can see here that we create an instance of the card, append it to the deck, and repeat and go through. The next section, I'm going to explain how to do the shuffle. So yes, Python has a random.shuffle. It's fine if you use that. However, this is probably a better way because you have more control over how the thing works. I've set this shuffle counter, I think, to be 10,000 shuffles, but you can have more or less. It doesn't really matter. So for each eye in range shuffle count, x equals a random integer, y equals a random integer from the deck, and then we basically apply the standard swap algorithm, which swaps the 2 cards around. If you swap the cards enough times, it's going to shuffle the deck for all intents and purposes as perfectly as we need.